Hello, Internet. Welcome to live streams, weekly show where I and today some of my guests streaming about some cool and interesting stuff in the world of stream processing, Kafka, open source, and many other friends. And I'm super excited today, super excited and super pumped that today I finally have my first guest. My dear friend, is Sergei Egorov, going to you live from where? Where are you? You're in Berlin.
Berlin, yeah.
Welcome to live streams.
Thank you. Thanks for having me. And I've been attending some of your streams, and I was like, this stuff is cool. Perhaps I should join. And here I am. So happy to be here.
For 26 people who are watching this right now, just like hit this like button if you're excited to have a Sergei here with me on this live stream. We have echo. I don't feel that you... probably, yes. As always, we need to check if someone is actually showing echo. I don't feel it's me. Sergei, can you check on your side if there's echo on your side as well?
Well, the only sound I get is my headphones. So please double check because I don't think it's me.
Okay, so I feel that I don't see how the echo will go through, and my TV set is not. So yeah, Dennis, check on your side. Maybe something else going on. Just give me a second. I will test it.
I will. And as any other stream, of course, it starts with some issues with broadcasting. Oh, that's fine.
No, I think
the world we live in.
Yeah, I think we're good in terms of the our dear echo from Berlin. No, it can be echo from Sergei. Sergei, there might be some of the how it's called, the microphone, maybe the capturing some of the sound that comes from your system, but I cannot hear.
Okay, let me mute myself.
Okay, we're checking the sound. Probably what is happening is I don't know what is happening. Anyway, so just like echo from Sergei. Just hit everything twice. Good stuff. Sergei, maybe on your computer you need to kill some of the YouTube stuff, or maybe your Zoom is also doing some. Maybe YouTube is doing something on your computer. Just like if you can mute maybe sound on the computer Anyway, so while we're trying to fix this problem, maybe there's some of the sound that come in here. Just let's make sure that the rest of the stuff will work great. Sergei is testing, and we'll bring it back Sergei in a moment, so Sergei can test his. Sergei, go ahead.
Okay. I muted myself while you were speaking, and if there was some echo, then it must be something else in your setup, because I did mute myself, and that's the only mic I have.
Yeah. So let me actually check. No, it's definitely from you, because I see that I just checked the stream, that on the stream you actually sound twice. So what is fix this problem, Sergei. So go in your system sound, kill your system volume, and after that just check in Skype that you select your device. Okay. And try. Okay, I see it. Sergei is muted. Check that you're using correct device.
So I just mute myself, and whatever I'll be talking will be just me talking. So. And I definitely cannot hear anything in the room.
Do you think you have any effects on your thingy that is on? Let me see if this will help. Let just talk to me a little bit and tell me.
I do. I talk to you, and the funny thing that it didn't happen when we were testing our setup. So I'm kind of curious. Maybe there's some leftover from the testing.
Yeah, we're testing. Yeah, it's interesting because I definitely hear something is coming from you. Let me check one more last thing. Is that maybe I muted Skype here? Skype is muted. Yes, yes. Be patient, people. We need to fix this. We got this. We got this. Okay, so I see the sound should go fine. You go at me, so it's going here, so everything's fine. So I do feel that nothing wrong on my side, pretty sure. Like Sergey on this in the stadium. Let's test one last thing. So in your Skype, if you go in your Skype and just select the computer audio, and maybe it's a computer audio is actually, I mean, like instead of the headphones, use the mic. And talk to me.
Okay, let's do that.
Okay, now I should be talking through the MacBook Pro microphone.
Okay.
Any better?
Just give me 1 second. The stream is coming to me, and I'm just testing. No, it's same stuff. Something is going on. Do you wanna? Let's see why Skype is going here. What about now? So people. What about now? Sergey,
okay, let me
talk to me.
Talk some more stuff. So I'm talking, and hopefully this time there will be no echo or anything.
Yes, I think it's winning.
So
I
it
think
was you.
it's winning.
No,
it wasn't.
you.
It was not me.
Of course.
Anyway, yes, it's winning.
DNS.
Yes, it was definitely some caching and buffering and things like that. Great, amazing. Hit like if you're also excited as we are. Once again, let's start this over because it's a good thing that in the post-production we can cut beginning and the end, so we can definitely remove this the problem with audio. But anyway, so thank you so much for joining us. I see there's right now. Sergey, you can switch back to your headset so we can hear your the clean signal. People, if you don't know Sergey, his Twitter, I'm just pointing onto his Twitter right now. Just go to follow him. If you're interested to talk about all interesting things around Kafka open source reactive. And today, we're going to be talking. What are we going to be talking? Sergey, I want to talk to you about one thing. And I always coming to you with like some weird requests. And one of the requests that I usually have that, hey, I need to have some proxy, say REST proxy or gRPC proxy for my Kafka. So instead of writing directly to Kafka, I will write through the proxy. And you always reply me to Viktor, you don't understand what you're asking. You don't need proxy, you need a gateway. And in this case, I was like, what? What are you talking about? So what are you talking about?
Okay. So first of all, some of my background, for those who don't know, I work for Pivotal, now VMware, and I'm into reactive stuff. So obviously, I'll be talking about some reactive stuff. And in my previous job, we kind of coined the idea of an event gateway, and that's the thing I was pitching to you when you approached me with some of the ideas, like how to access Kafka without going directly to Kafka. And the idea is very simple. Like, we used to put gateways or proxies, reverse proxies in front of our HTTP services, right? Like Nginx, Apache HTTP server, and others. Why we were doing it? Because we wanted to kind of hide internal infrastructure, and we wanted to expose only a subset of this infrastructure, or maybe we wanted to apply some filters, some logic. Maybe we wanted to go request to foo to one server and to bar to another server. So anyways, it all kind of ends up with a simple idea. What if we proxy everything? What if we gateway everything, every access to the target system? And in this case, target system will be Kafka, will be Apache Bursar, will be any other Kafka-like system. That's the concept, event gateway. We start gatewaying thing, we start proxying the thing. And unlike, let's say, Kafka, we'll use some simplified protocol. We don't need the complexity of, let's say, Kafka protocol when we just want to publish a message, right? It can be as simple as, let's say, gRPC endpoint or even HTTP endpoint, why not? But publishing is easy, while consuming is streaming, and doing streaming isn't as easy as it usually is with request response. So we cannot just use REST, right? We cannot just use HTTP. So we need something else. And this is where event gateways, I think, will shine.
Okay, so we are, in my opinion, like we're complicating the architecture by bringing some other stuff here, right? Like
Of course. Like
let's
Kubernetes.
perfect. Let's get to it. Let's get to it immediately. So you got my attention when you said the Kubernetes. Like you immediately will get my attention. So so what we're gonna do today? We're gonna be first of all, we're gonna see how this like a pair programming and the pair teaching and this type of stuff can be exciting, can be fun, and maybe you as I also will learn something. Let's see if you have anything, any good comments here.
Mostly about sound, I guess.
Yeah, exactly. The people always bragging about sound. People talking about that we should use ICQ instead of Skype. Thank you so much. You're very funny person, Alexander. Thank you. We're looking forward for other comments. If you don't know why we're using Skype, I did previously did a stream explaining the technology around this live streaming. It is not easy, guys. If it would be easy, everyone would do it. So let's switch to screen. So now the Sergei, we see Sergei's screen, and Sergei will lead the way, and after that I will take over some of the coding, and we will be like building something collaboratively. And so since Sergei already brought us idea of the Kubernetes, that will be here somewhere. Please, mic is yours.
I mean, it's 2020, right? So we cannot do live stream without Kubernetes. So I'm gonna create a cluster. And the whole idea of what we'll be talking about is that you can start from scratch and you can implement a very complex system just by doing simple things. Like first I will need cluster. So I'm gonna create a cluster. I'm not even using existing one.
Yeah. So one of the things that we also like want you to have in this stream is not only having interactivity part in the chat, in the comments, but also we have interactivity with audience who will be, maybe, typing.
We'll see what we can get from the interactivity part. But anyways, now comes the hardest part, the name. Damn it, what should we use? What should we do, actually? I mean, we could do, what can we do? We can do to-do application, but we are doing JavaScript, right?
Live streams. I always call it live streams. So
no, it's too generic. Like, okay, live streams, but what else?
So what about this?
I know to-do app of 2020. It's COVID tracker.
COVID tracker. Yes, let's do this on.
Okay, let's do COVID tracker.
Okay, so people still hearing echo. I think it's phantom echo that people might hear. Right now, echo is not there. Just like It's all
Okay,
right.
anyway, so I'll create a tiny cluster. It's just 3 nodes, and it should be enough for what we want to do. And I'll kickstart everything, and we'll start creating a cluster for us. And the cool thing is that we'll be creating a public cluster so that everyone will be able to actually send requests to the endpoint we'll later expose. So if you want to participate, by the way, please feel free to. And if you want to do what we will be doing, it's also up to you. But we expect some of the attendees to do some stuff because it's too boring just to watch me and Viktor talking, obviously.
And especially, you will have opportunity to code with us together because maybe you can code faster than Viktor. And everyone knows that Viktor's not coding anymore. It's all about marketing and self-indulging.
Let's be honest with you. You're not Josh Long. So some people out there may be faster than you, but I'm sure you'll be as fast as needed. Cool. So we're creating the cluster. And yeah, we're not talking about the cluster. We're talking about the event gateways, right? So I guess I need to introduce some solution to the problem. Otherwise, it would be kind of weird. Like, what will we do? We'll write our own event gateway or something.
Yeah.
It's obviously not a standard. You cannot say that it's a standard as, let's say, Nginx or Apache or something. We're talking about new cool thing, but it's just, getting started. And for that, I'll be using my own project because otherwise, probably
what's the point, right? So what's the point not using the project that you wrote yourself?
Yeah, exactly, precisely. So today, actually, we'll be talking about Liklus. And for those
majority of this presentation would be about teaching how to pronounce this Liklus correctly, so the Viktor will not make these mistakes in the past.
Yeah, so codename Patlus, so Liklus. I used to live in Estonia, so when I started the project, I was looking for something, and I was inspired by Estonian language, and apparently Liklus means traffic in Estonian, so I really liked it, and that's the project name. Maybe not the best project name, but at least it's very easy to Google. So anyways, we are talking about an event gateway, and as I mentioned, we cannot just use HTTP transport, which means that we need some other protocol, some streaming-friendly protocol. And when you start looking for streaming-friendly protocol, you'll obviously end up seeing RSocket, gRPC, and a few others. And the cool thing about Liklus is that it's not a new protocol, and you don't have to learn a new client. You don't have to learn a new binary thing. You can just use your knowledge of gRPC or RSocket, and yeah, you can connect to Liklus via gRPC if you already know gRPC, which is kind of cool. As I said, we are talking about Kafka. This is why, Viktor is here. And Liklus supports Kafka. Liklus supports a few other storages like Pulsar, for example. But today, I think we'll be talking about Kafka.
Yeah, I will need to bring my shotgun, and we'll start talking to people about Pulsar holding shotgun. I'm just kidding. I love you guys. The Pulsar is amazing. It's just like another great technology, more great technology. We will talk about this. So let's do this. If the stream will hit, say, 200 likes, if we have a 200 likes, one of the streams that we will do with Sergei, we will use Pulsar as a storage, and we will be showing how we can use this with Kafka. So, you know what to do, guys. It's 200 likes. Yeah, 200 likes is not just like we can do that. Yeah. So essentially, I think one of the things that I was missing at the very beginning. When we were talking about the concept of the proxies, because in my opinion I was too generic, right? So when I talk about proxy, we definitely will be relying on the system that we're proxying to, right? So we're going to be talking about Kafka is going to be Kafka proxy, or it's going to be Pulsar proxy, or it's going to be Kinesis proxy. So in the idea of the gateway, it needs to be more generic. So it will not be, depend on the underlying protocol much. So your application would be writing against this gateway. And it really doesn't matter if your application wants to use Kafka or it wants to use Pulsar or wants to use Kinesis or wants to use something else that maybe some of our listeners and viewers are developing right now. I also, for those of you who asked to make the Sergei louder, I just did, and let me know if he sound better to you.
Okay. So as I can see, you already did your homework and researched the topic a bit, but that's exactly how you say it. We're not talking about proxying the same protocol, but we have a meta protocol that will help us connect to various systems, hence gateway, and not just the proxy. And not just that, but we are talking about some reactive gateway. And this part at this part we may lose some. I hope we will not. But anyways, why we are talking reactive here? I already mentioned that reactive is my thing, but probably we should explain why reactive. And the explanation is
exactly because it's your thing. Just go ahead and explain this.
Okay. So, what is reactive after all? It's a simple concept. We just have a clean synchronization on the request, on the consumer demand with the producer, and the whole thing is asynchronous most of the time. And when we are talking about Kafka, let's say, when we want to consume events from Kafka, we don't want to consume them like, give me all the events you have, right? If we can only process one event per second. If we process one event per second, probably we want to request like 100 events or 1,000 maybe at most. And then we are slowly processing them and request more. In Kafka, this request part means poll call. So when you do consumer.poll, it kind of means, hey, give me more. In reactive system, well, you don't need to do pool-based API. You can just say, I'm ready to accept at most 100 items. And then the producer will produce at most 100 items. So it's a perfect match of two systems. Kafka, where you can stream things, and reactive applications where you say how many items you're ready to accept. The only question is how to communicate. Unfortunately, we don't have many reactive clients at the moment, and the ecosystem is growing, but some, let's say, the official Kafka client from Confluent or from Apache Kafka in Java, it's not reactive. You can do a reactive wrapper around the Kafka client, but if you want to be reactive all the way down to your system, then you need to do something about it. And Liglus is essentially a helper here because it transforms everything into reactive first system, where your source of data is reactive, and then it's up to you how to consume it in reactive way or in synchronous blocking way. It's also possible, we'll later demonstrate it, but here we are talking about reactive first, which means that if you are reactive already, then it's a good helper in your infrastructure.
So let's do this. Since it's a reactive first, let's start with the Liglus first without anything. Can we do that? Like forget about Kafka. Like let's see how this stuff is working.
You mean deployed?
Yeah. Just like ship it. Ship it. Let's start. It's a good idea, but it's my thing. Like only talking and not showing anything. It's but we right now in 2020. Yes, we're in 2020 right now, so we cannot do just like a talking conference. We need to show something because otherwise.
Right.
Hey, so let's do it.
Okay, and we want to here because we already created Kubernetes cluster, so we already did something. Anyways, let me quickly check that we have cluster running. Cool. Seems that we do.
And meanwhile, we're also wishing the good health to Kevin, who's one of the contributors to Test Containers project, and he said he's right now sick. So be well, my friend. get well soon. And thank you so much for joining.
Get well soon, Kevin. And we're happy to learn that it wasn't that virus. It was just regular sickness. And
maybe just a hangover as a rock and roller. So
yeah,
probably just a hangover.
So, anyways, what do we have here? We have a Kubernetes cluster running, an empty one. So I can check that we don't have any pods running, and yeah, no resources found in default namespace. So we need to deploy Lickless, because let's just play with it, right? Let's stop talking and let's just play. First of all, we need to check whether we can run it as Docker image, because obviously we're talking about Kubernetes, means Docker images. And yeah, it comes with some nice stuff, like you can run the official image from Lickless. So that's what I'll be doing. Just maybe
and it's just again for 2020. If their software is not available as a Docker, you as a software vendor need to consider your your life choices.
Yeah, exactly. So I'm not sure if our listeners are aware of Scaffold, but I will be using Scaffold as the easiest way personally for me to deploy stuff to Kubernetes, because I keep forgetting all the flags and how to do k-apply, blah, 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 and how to reapply. So I'll just be using Scaffold, and later it will also be helpful for doing more things. But anyways, here I have a very basic Scaffold application, and it says that the manifest will be taken from the infrastructure folder and every subfolder. So I'll just create infrastructure Lickless. And no, it's not my Mac keyboard, but it's actually double I. So yeah, be aware. And obviously I need to create a deployment, right? Thinking whether we should be, writing it from scratch or not. But anyways, let's do that. Let me refresh my knowledge about Kubernetes.
And YAML. Put some likes here if you want to see this version of this deployment thing in Kotlin. This is also something that we can do. Just like a type into chat if you into YAML person, or you are Kotlin person, or any other programming language generated stuff. Like personally, I cannot type YAML without special tools. And as you can see here, Sergei is writing down YAML.
Yeah, I'm actually surprised that so far I'm successful at writing YAML. But anyways, we need a Lickless container. And as you can see, I'll be using one replica for now. I hope that's fine, but later we may scale it to more instances. And,
can you click Command plus a few times so the font would be slightly bigger in your code? Command plus.
Oh, the funny thing, I do press it at the moment, but nothing happens, and I'm surprised. So let me just use something like zoom in. Oh. Okay. I hope now it's better. And I'm surprised that okay.
Yeah.
Exists.
That's good. Okay, so basically it's just one of the things that I can point out from what I see. So we're using simple deployment, meaning that this application, this Lickless guy, is going to be more or less stateless, right? Because the deployment, you don't care about stateful name identity, you don't care about stateful disk identity, so you don't really care about these things, right? So it is going to be like a very lightweight, essentially, right? So since you're using just a simple deployment, you're not using stateful set, you're not using anything like that.
Nope. And actually, the cool thing is that it's a deployment, and it's stateless.
Yeah.
And we'll be talking about it more, but it's an important thing to understand that you can scale it horizontally without any issue, and it will never require, keeping the state or preserving the state. So anyways, here I need to use the image, so I'll be using the official image. Just maybe with one exception, I want to use the latest and greatest so that I can show more things to you. And let's check what ports does it expose. So first of all, there will be an HTTP port, and it is port 8080. What is port 8080 of Liklus? It will be just a port you can use to do some stuff like house checking and other things. We'll later explore, but this is a regular HTTP port as of any other service. But the next one is more interesting, like 6565, and now we are talking about gRPC, so that we can connect to Liklus over gRPC, or if you are into more reactive-friendly protocols, then you can also use our socket, of course. And a socket port will be 8081. One last thing is environment variables. And if we just start this container, like let's just start it locally.
Yep. Woohoo!
Okay, it's starting. Boom! It fails. Why it fails? It says that storage positions type not found.
But
okay.
you mentioned that we don't need to do any storage right now, right?
Well, exactly. We don't need to store anything, or Liklus will not be storing anything, but it also means that we need to offload the storage to some place. And in production system, it would be, let's say, Kafka for the records and some key value storage for the offsets or positions. But here we want to test it. We want to just play with Liklus, or maybe we are running testing.
Yeah.
So I'll just set it to positions type equals memory. If I start with just the memory type, it happens now. Records type is missing. And that's where you would be using Kafka, for example. But now we don't want to use Kafka. We just want to start with something simple. So I'm just using memory. Now, if we start Liklus with in-memory position storage and in-memory record storage, it will start just fine. And as you can see, there is a huge banner saying that you should never be using position storage and in-memory position storage in production, and you should never be using in-memory record storage in production as well. But the cool thing, you can use it in tests. So you don't need to start Kafka.
We will talk about testing. A few questions in our YouTube chat. So, is Liklus built on top of Neti? Because people were able to see some of the exceptions that happened propagated from Neti. Is Liklus use Neti?
Yes, it does use Neti, and actually from some more traces, I think yeah. I mean, this one is obvious.
Yeah.
It's a Spring application. String, really. Anyways, it's a Spring application, and we are talking about Java here.
Nice.
Doesn't it surprise you?
Well, I mean, it's 2020, and the cool kids are writing these services like every day in Go these days, and it is surprising me. But like, why why are you writing it in Java?
That's a good question, and that's one of the most popular questions about Liklus. But actually, the question is usually why not Golang? And the good answer is that Java comes with a lot of built-in or like a lot of ecosystem projects. For example, you want to use Kafka. The best client out there is Java client from Apache Kafka. It's a native client, and you don't need to worry about some features not being supported or anything. And I remember seeing a very long conversation about selecting a Kafka client in Golang community, in Knative community. I think they spent like half an hour just talking about different options.
It is because it's a Go community. They just like spending time talking about things. Same as the Scala community. So
could be.
Yeah.
Could be.
This question from the chat: is it like a Neti, like a plain Neti, or it's a Reactor Neti?
It uses Webflux under the hood, but only for the HTTP part. and the rest is handled by gRPC and RSocket. But yes, it uses Reactor native under the hood, especially for RSocket. It is the same Reactor native.
While we're still answering some questions, we have a question from the Alexander. In the YAML, I saw something new to me that was not TCP UDP, but was gRPC. So you can briefly describe difference in whatever it works in GKE and whatever, can it work not only in a super fancy, super expensive cloud that we use?
That's a good question. And to answer the question, I suggest we go back to YAML, because we are going to write a lot of YAML today. And let's just enjoy some more YAML. And well,
enjoy YAML responsibly.
Yes, but that's just name here. I could as well write, I know, poop, and it's gonna be a valid name.
Same way as gRPC. I'm just kidding. Yeah. So this is for Alexander and for other listeners. It's just here we're defining the name of the ports. But what's important here is that what actually goes into this port. As long as it's TCP, any type of like level 4 protocol, so it should be fine, right? So so it's just that so when you're writing something, think more about not what you're writing, but who will be reading this. So the people who will be using this deployment, they would understand that, okay, this is going to be TCP protocol, this is going to be gRPC protocol, this is going to be RSocket. All these protocols can be laid out on top of, level 4 TCP protocol. gRPC laid out on top of HTTP2, which is on top of, level 7 protocol. So yeah, that's welcome to YAML hell, exactly.
So let's write some more YAML, and
let's do it.
We need to set some environment variables. And just to simplify the deployment for the moment, I'll just use the memory option. So storage, positions, type, and value will be memory, and storage records type value will be, can you guess?
Memory.
Exactly.
So I was thinking, in this case, can it use a Hazelcast to store this record? Like for many of listeners, they remember my past of in-memory evangelist as well. So every time when I see memory, I was like, hey, can it be distributed memory?
I have a joke about it. Today, some guy on Twitter, he commented on the picture, like, is it a real tattoo? And I was about to post an answer saying that, hey, you should have seen his Hazelcat tattoo on his butt. But then he deleted his comment. So it was kind of like, dude, why did you delete it? Like, it was such a great joke. But yeah, now it's only recorded on this live stream.
Yes. Ask me next time if I have a Hazelcast tattoo. I cannot show you. I cannot show you today because the camera is set. On position of the camera is not super convenient to show this tattoo.
Got it. So I think we have enough YAML to run this thing. And I'll be honest with you, that's like a lot of YAML. So I may have missed something, but let's just try to run it. And to run it, I'll just use scaffold run. Yeah, I really like, short options. And here I'm using Ska. Any Ska fans out there?
It's a type of music when they need to use like how you call it, trombone.
Yeah, exactly.
It's I don't remember what's the name of the musical instrument.
Dude, you should really be careful with doing such things because people will make GIFs out of it, Just be careful.
Yeah, I'm still waiting. I'm still waiting my 200 likes so we can talk about Pulsar on the live stream. So people, do it. You know what to do.
So I just deployed some Kubernetes. I just threw some stuff to Kubernetes, so I need to have a look how it's going. I'll be using Octant for that. And for those who don't know what Octant is, I would like to ask a question. Do you really watch what Viktor is showing? Because he has a great blog post about different tools in Kubernetes ecosystem, and Octant is one of them.
Yep.
So yeah, just have a look at his blog.
Yeah, the Viktor is here doing some cool educational stuff, and
YAML.
no one cares about. Okay, can we pause this for a second? So what I see that your application started in just 1 second. Is it is it like illegal? Is it? Are you using some the modern like cool magic that using like a Graal VM and some native images?
Not even that, and apparently, turns out, guess what? You can run Spring applications really fast. Just you need to properly configure them. And here I have Spring Boot application running with some Spring Foo magic, so that it starts very fast in just less than 2 seconds here. Or like, okay, total time is 4 seconds, but it's nothing actually. And I have a tiny cluster with just a bunch of CPUs, small bunch of them. But anyways, yeah, for those who think that now we will never be using Liglus because it's not in Golang and it starts in like 1 minute, just, yeah, it's not always like that with Java, and modern Java is actually pretty fast.
So think about this, guys and ladies who watch us. The what is more important to you these days? Is it like to learn some new cool technology, or like be productive of the tools that you are productive with? So one of the things that Sergei just mentioned, there's like a variety of different libraries available, and for the tools who like written in Java.
I love this comment. Why not Micronaut? And I'll answer not as a Pivotal employee, but as a Java developer. I used to write a lot of Spring applications, like up to 50 or maybe even 100 services already in Spring. And why would I change my tool set? Well, why would I change my framework if it starts fast? If I know how to get shit done? Oh, can we say this word? I hope we
Shit,
can.
of course. We can say
Perfect.
shit words like as many times as we want.
Perfect. I will not be abusing, but sometimes I need to say them. Anyways, yeah, I know how to do things with Spring, and I don't want to learn another framework or anything. For what reason? Like, why should I? Anyways, I'm Spring fanboy for years, and yeah, just
next time,
that's what makes
if
me
this
productive.
video will get 300 likes, Sergey shows his spring tattoo.
Okay.
Okay, so now we started. Can we do something with this useful? So now you mentioned this. You have this type of stuff deployed in Kubernetes.
Yep.
Can we provide external access? And for example, I type something in.
Well, let's first of all check whether it's running fine or not. So just go into the container and do some curl. Why not?
Yeah.
And I want to check the house status of it. It's okay. And I could even query some other things like Prometheus in point. And we will check it later. But anyways, Prometheus also responses okay. So apparently we have Liglus up and running. But yeah, some Kubernetes experts will ask, but how can we access it, right?
Yeah.
We don't have a service for it.
You need to have either service that will be attached to load balancer. So let's deploy this.
Yeah. So I could actually do local port forwarding, but then it's only me who can access it, right? So it's not cool. For that, we'll create a new file. And by the way, if you think that Liglus is Kubernetes technology, then I would say that no, it's not. And actually, I've been using Liglus in classic Docker environment. You can also run it as Java application, by the way. I don't even need Docker. Just it's more convenient with Docker. And here, what I'm doing is actually it's me first time trying, or okay, maybe not first time, but like this attempt is one of my first attempts at running Liglus in Kubernetes. So I'm learning the same way you are learning thing, and I hope
It's actually makes sense. Just like again, in order to make this, I'm just like talking to audience while you're typing, so we don't have this awkward silence moment. So things what we're trying to do is to come up with some demo that will be it's running demo through a few weeks, and where the people can also interact the way how we can interact. And for me, I would say there's another approach that would be maybe a little bit simpler that Kubernetes these days, like we can run something in Heroku or Pivotal Web Services. Easy, right? We can also do this, but in this case, we kind of like sticking to the specific technology and platform, and people saying, "Oh, they paying you." We're just doing this Kubernetes, so it would be cross-platform.
So, I just produced a lot more YAML. So I'm obviously YAML factory. Some Spring joke here.
Yeah.
Okay. Anyways, so I produced some YAML, and let's go through what we have here. So as I said, gRPC and RSocket, these are not HTTP-based protocols, but we need something that will allow us to connect, in streaming fashion, blah, 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 which means that we need to use TCP protocol here. But it also means that we cannot just use ingress, because ingress, a classic ingress in Kubernetes is HTTP-based.
Yep.
For that, we'll just expose a load balancer load balancer to Liklus. And now, when we send a request to port 6565, then it will go to load balancer, and then load balancer will proxy this request to Liklus container on port 6565 without any HTTP parsing or anything. So you need to use TCP-friendly services for Liklus. You cannot just use HTTP.
Well, some of the ingress controllers support that. So if you're using Nginx as your ingress controller, you can pass the level 4 protocols like TCP. But by default, it might not work. So in this case, load balancer is usually portable and very safe bet to use.
I think there is also SNI-based routing, TCP routing. Not sure whether it's generic in Ingress or implemented by Ingress implementations. But anyways, here we'll be just using load balancer.
Yeah.
And I'll just redeploy the thing, or actually I'll just deploy the service.
Yeah, we have Masood that he mentioned that Nginx supports gRPC, and they use this in production. That's amazing. This is exactly what we mentioned. That
you know what? Some next episode we'll try it with Nginx, because load balancers are expensive as hell. Okay. Anyways.
I like this tool. I like this SKA tool. I like this scaffold thing. It's definitely have some inspiration on Helm side of things, right? But it doesn't have any repercussions in terms of
so you just
server
dropped
side.
The Helm bomb.
Yeah. So you don't need to have any like external things. Okay, so what I can do here, I can also do curl. Wait. No, let me do this.
Yeah.
Let me do this for you. So let's make this a little bit interactive. So where's my console? Where is it? Let's do this interactive as well. So we're doing this curl, or I do HTTP. I'm using HTTP 13.
Just make sure that your screen can be seen.
Oh, yes. People see my screen right now. And I'll do what? 8080?
Yeah, just house.
Health. Yep, I'm just mistyped. And we got okay. So I just confirming that we just have a connection to where's your cluster in Frankfurt? From New York to Frankfurt,
Yeah.
we just get connected. So while
Okay,
it's working, there's another question from Alexander. Question a little bit ahead of time. Who's responsible for retry circuit breaker app or leakless or something is not covered? If Alexander runs in front of gun, you can answer. If you can answer with short answer, please, by all means.
You know what? I think it will be just easier if we try it ourselves.
Okay.
Let's just keep the question for later, and it is indeed ahead of time, but we will be covering it today. But actually, we just got okay response from Liklus deployed to Frankfurt. Maybe that's enough for today. We deployed
No.
stuff to Kubernetes.
No, it's just we just started. Like, what are you thinking about, guys and ladies in our chat? Like, should we continue or you already, seen everything? Because, we deployed stuff in Kubernetes.
That will be the worst episode
Yeah.
of this stream.
Like,
two guys spend time deploying stuff to Kubernetes that should take like 5 minutes, right?
Okay.
And they were talking about it 50 minutes.
So the Kevin is trying to identify my the keyboard switches sound mechanical but not clicky. Yes, they very low profile red switches or brown, red. I'm using red switches, low profile, not super clicky. Thanks for this question. I wanted to opportunity to share my new keyboard. So there was a question about our socket. Sergei, the way to support our socket traffic working in Kubernetes is defining by load balancers. Can you clarify this? Looks like it's nothing. It's not clear.
That's a good question. And currently we are using TCP load balancer for both RSocket and gRPC. And as was previously mentioned, gRPC is already supported through Nginx, I think, or maybe just normal ingress. But anyways, speaking of RSocket, and some of you may not know what RSocket is, or I would actually expect that not like most of you are unaware of RSocket. But RSocket is an effort by some major vendors like Netflix, Pivotal, Facebook, and a few others to define a reactive-first protocol for interacting between two endpoints. And I intentionally say it not between client and server, but just two endpoints, because as soon as you establish a connection in RSocket, you have a tunnel. And then it doesn't matter how the interaction goes, from the requester to the receiver or the other way around. It's a very powerful protocol, and it supports different models of interaction, such as request response, request stream, fire and forget, and channel, where you have bidirectional streaming. And another cool thing is that you can also push things to the requester. So let's say you have a mobile device and you have a server or service, and now you want to push something to your mobile device. With RSocket, it's implemented out of the box, and you don't need to poll for, hey, are you ready to push? Are you ready to push? Are you ready to push? No, you just define that I'm ready to receive the following requests from the server, and it's a very cool thing. I really liked it. I'm probably overexcited about the protocol.
So,
but there was a question.
Hold your horses. Yeah, I think the short answer, in my understanding of this thing, is that every time when you're starting like new project, like from scratch, so maybe some greenfield project, and you already set on some what's the word, like transport protocol, like it's going to be HTTP or TCP, you still need to come up with the way how you form those bytes. What exactly going to be pushing there? Regardless, if you're doing this HTTP, you will be using most likely, bytes would be serialized as a text, as a JSON. If you're using TCP, you probably will come up with some sort of like protocol how you pack these bytes. So our socket already provides unified ways, and you just you don't need to even define the transport because it supports TCP. So in this case, you have level 4, and it can support. Aaron is also level 4, right? So it's also on top of TCP, and WebSocket is the level 7. So in this case, you can use this and with different scenarios. You can use this with scenario where you have a low-level TCP communication, or you have the protocols like HTTP, and it provides all this kind of semantics for request response and streaming, which is pretty good. For example, WebSocket provides you how it's called with the bidirectional communication, so you can do streaming, you can do push and things like that. So, but it's abstraction from transport. Okay.
As long as you can establish a socket-like connection, you can also exchange RSocket data over the connection. And as you mentioned, for example, WebSocket is also a supported transfer for RSocket. And to answer the question, no, it doesn't mean that for RSocket you must be using load balancer. Actually, you can also use WebSocket transport for RSocket, and then WebSockets are already supported by ingresses, if I remember correctly, because it's just TCP upgrade of the HTTP request, and it's a very flexible protocol with an abstraction on top of other protocols like level 4 or level 7 protocols. So definitely have a look.
So the reason why we're using load balancers in this particular case is just so like I would have access and you will have access to the same server, so we can communicate. But there's definitely different way of communicating. So let's see what we can do next. So okay, we do have this service deployed, right? So we have this service deployed, and what next we can do here?
Well, I guess it would be a failure if we are talking about event gateways without sending any events, right?
Yeah.
So probably you can send some events to Liklus.
Okay, so I already have Liklus deployed, not deployed. Like I have a clone of this Liklus thing in my computer. So like what I can do here? Question to Sergei.
Have a look for some examples, maybe.
Perfect. Yes. So this is what we're going to do. So I already have this. Let's see if we have any examples that allows me just simply produce to our service. And in this case, Sergei will be receiving those. Let's try this one. So I do have examples, Java. Let me see if I can do presentation mode so people would see this as well. Cool. And let me get this out of the way. So in this case, we do a consumer. I don't have there's no example of consumer, so let's create example of producer.
Okay. Actually, if you look at the consumer, then you may find some existing code for sending events, because otherwise example of consumer without any events in the system would be a no op. So maybe you can just copy and paste some of the code from the example.
Okay.
Like, why not?
I do have it. I do have it in my screen, and let's see. So So first thing that we need to use what while it's still building, it's supposed to be.
Oh, actually, you know what? Before we continue, I think we were talking a lot about gRPC and RSocket, but we didn't talk about what I mentioned before, like simplified protocol. So maybe you can get, maybe you can give back the control to me, and I'll do a fast exploration of.
Yeah, you have a control.
Okay. And Liklus and the protocol of Liklus is a standard protobuf protocol. By standard, I mean as long as your technology supports protobuf and gRPC and RSocket RPC, for example, you can also connect to Liklus. So here I have a proto file, and this is my service, Liklus service. It's very, very easy to grasp because it's just a bunch of 6 RPC methods. to publish, to subscribe, receive, acknowledge, and some offset-based API. And the good thing is that that's everything you need to know. As long as you know these RPC methods, you can send events and you can consume events. And we are going to explore that. And we will skip the part where we generate required types from the proto files, because we already have them in the project, most probably. But what I wanted to say is that you'll find information on how to work with proto stuff, or proto stuff is actually a project, so I should not be saying proto stuff. How to work with protobuf.
I have a question. So if I will just use the command line tool for interrogating gRPC service, I should be able to do this for Litless, right?
Of course.
Yeah, let's try this one. So I just literally just Google how I can install this. There's the command line tool called grpcc. So let's see if I be able to install this and play around with this.
Go ahead.
Yeah. So while it's still installing, and
actually,
for the record, guys, it's just 100.
Introspection.
Yeah. For the record, it's just like a totally unscripted, and we never tried this before. So, which is a cool thing about this this type of show, right? grpcc. It says proto. We're taking proto file in, where is it? Is it in protocol? It's a protocol src main proto Litless service proto address.
I just want to give you a hint.
Yep.
Victor.
Yes.
Litless supports gRPC introspection, and gRPC CLI knows how to read service definitions and message definitions from the running server. So you don't actually need to compile gRPC locally, but you can use the CLI and it will encode everything for you.
grpcc address 6565, right? It's our...
Yep.
Okay, so it throw me some errors. Failure to load gRPC binary model because it's not installed on the current system. No way. I thought it is. I thought I have installed my gRPC. So in order to install this gRPC, I need to go to brew, probably, right? Install gRPC, maybe. I don't know. Like, see if brew will fail. It's interesting. So while it's it's compiling or looking for the things, we can let's see if it will execute things.
When you'll be publishing requests, when you'll be publishing things, make sure to use the event and not just the value, which is deprecated now. But the event is defined as Litless event, and when you look at Litless event, you actually do you see some similarities with maybe some other standards out there?
It looks like reactive the manifesto.
No, it's not. Have a look at Litless event.
Litless event type source data map. It looks like a, I don't know, Kafka event maybe. ID type source.
If only there was some standard for events.
Or maybe it's like a cloud events maybe.
Yep, that's it.
Nice.
Yeah, actually publishing cloud events.
Which is super cool because it is a kind of like a standard thing to deal with. For some reasons, my thing is failing. Let me see. Maybe I need to reload. Bloom Postman for gRPC. Alexander, can you throw me some link that I can install and play around just right now? Let's see. Let's see it once again. Nice. Okay, so I need to have a proto file. Protocol.
Or you can use introspection.
Which I need.
It's a really cool thing.
What's the introspection flag that I need to pass here? proto directory address service, proto liquid service. Let's see. Import Google timestamp proto. How I can use introspection?
I'm checking that for you.
Proto directory service. Name of the service to connect to. Eval exec script. Okay.
I think you could just pass the address and drop the proto argument, and it will load the schema from the target server.
Let's see.
I'm not sure.
I tried. I think I tried. Didn't went through because it requires some of the proto.
Okay, then just use the proto file.
So proto should be valid. Okay, path to. Okay, so when I run this, it gives me error that it cannot import the protobuf things. So
Okay.
So right now it says like failed to import the timestamp.proto into Liklus.
I guess we are going to spend a lot of time trying to get this thing working, and
exactly.
I see that this is Node.js, so I'm not sure we should continue fighting with this Node.js too.
Let's see if I have a Bloom gRPC. If it's like a Postman, Bloom GUI client for gRPC services. So you can continue talking a little bit about this. I will try to install this guy, and maybe we will have a better luck with another client, which is super cool. Okay. You're also installing. Okay, let's see.
Yeah.
Let's see.
I know that Dave Sire from Spring Cloud team, he was sending events to Liklus via gRPC, if I remember correctly. And he actually is the one who contributed the introspection to Liklus. How cool is that? Like, if you know Dave Sire, he's legend, like Spring Cloud legend. Oh.
Okay, installing this. Yeah. Good Dr. David Sire.
Yep, doctor, exactly.
One commit, but hey, this commit is legendary. Okay, installed. Okay,
oh,
let's
gRPC
see.
curl. Okay, gRPC curl. That's the one you're looking for.
Okay. Okay. So my gRPC. I will install this Bloom thing. Let's see if we can get this gatekeeper. Don't do this at home, kids. Do not open any applications that you just download from internet. But hey. Okay, so now we have and what's the port we have in our 6565, right?
6565, yeah.
What's the address? Copying this address here. Server address. Okay, so let's go. Will it be able to connect? Save environment, server address. And so what we need to send in editor? Can we? What's the command that I can send there? Come on.
Yes, you want to publish. Make sure that you select plain text communication. And meanwhile, I'm almost describe. Yay!
Works?
Okay. Yep. gRPC curl.
Okay, so just
gRP curl.
What's the gr curl? Okay.
It's like
installing.
curl, but with gr.
Okay, loading. It's going up.
Now I'm curious how to send requests with gRP curl.
So we have an address. You said plain text, right? Plain text and gRPC URL plain text, and you said describe. Yay, it works. I see it. Yeah. Okay, cool. So we play around with this. We're thinking like it's not only HTTP works, but also the the gRPC works and HTTP works. Okay, cool.
You know what? We can continue with Java version, and meanwhile try to do it via gRPC curl. What do you think?
Okay, let's do that. So I'll try to stick to Java version. Let's see if I can do this. So you will see on top of the screen, you will see the Sergei's terminal and my terminal on the bottom of the screen. This is how this like a pair programming stuff should work in, right? So meanwhile, I'm exploring how I can do stuff with producer. Let's see. Okay. And
okay, I'm about to send this command.
Okay, I'll just do class. We call it producer. Producer. Adding here. For some reasons, I need to update my PHP. Public static void main. If you feel that my computer is not super responsive, you're right. My computer is super not responsive for the reason that I'm running multiple things here, including live stream from my computer. So that's super cool. All right, so we do what's this our port? This is our port. This is where our stuff is going to be. Let's call it a URL. And
can you switch to my screen for a second?
Yes.
I have something awesome.
Okay.
So I was finally able to send a request with gRPC curl. So I don't even need Java to send requests to this thing.
So for those of you people who are in a chat and still alive, Sergei, can you post this command or like the show this command how the people can produce this and if they can do this from their side, and on your computer you can run the consumer so you can read all these messages. That would be also cool. It's a cool bit of interactivity.
So it was actually pretty easy. So first of all, it takes standard input, and then you pass JSON to the standard input that should match publish request. And here I was using topic, skipped key because it can be null. And then you need to provide Liklus event. And in Liklus event, you have 3 required fields like ID, type, and source. And that's the bare minimum that you can pass to make it work. And then use gRPC curl -d add so that it will take standard input. I just got it from.
I mean, you can just like copy this thing into our chat, and I will distribute this in our YouTube channel.
Sure, I will. And for those who want to play with this, it would be cool if you just publish an event where, for example, let's say this field, data, will be your nickname. Like, why not?
Or so maybe even say source. Let's just say in my
or
side.
Source, yeah.
Source is going to be, say, New Jersey. And my, what's the type, blah, 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 ID. What when you want to replace ID? Let's do, on your side, do you have a listener right now so you wouldn't see, like run the consumer, right?
Not yet, but let's quickly get some listener running so that we see the events we are receiving. So I'm gonna need the IP once again, and here's my external IP. And I'm gonna switch to the consumer example. There's a method get liquidus target. So I'll just replace it with 6565.
I just post the command in our YouTube chat so people can participate if you have this like tools installed.
And I need to change some things, like I think we were using events as topic, and group. So first of all, what we have here, let's just go one by one. This is standard gRPC stuff. We'll be using a native gRPC native implementation, and we'll be connecting to this legless target. As I said, I use reactive processing so that I don't need a pool of threads. I'll be just using direct executor and plain text to connect. No TLS here. Also, you can use TLS if you want to. Just here, I simplified the example. And I need to have an instance of this service so that I can call stuff. It's almost like Corba and other things from the past.
Yeah, gRPC, it's the Corba for cool kids.
Yep.
Like there would be any generation of developers need to invent their Corba. So.
Yep. So anyways, I need to have an instance. And here I'm using Reactor or reactive gRPC project, which will generate Reactor client for the target service. You can also use standard blocking gRPC. But anyways, here I'm using Reactor gRPC because I find it more convenient. I create a stub. That's the stuff you'll find in the documentation for gRPC and for Reactor gRPC, nothing Liquidus specific yet. But now, as soon as I have a stub, I will have the same methods. Remember, this publish, receive, subscribe, blah, blah, blah. So the same methods. And to subscribe, now just, doing stuff here. I need to pass a subscribe request. So I'll just move this line here. And let's inspect some of the fields of this subscribe request. Topic is events, because if I remember correctly, I was using topic events. Yes, exactly. Group is the same as in Kafka. You want to group your services, your consumers, so that you balance the load between the instances. You can scale them out as soon as you have, more than one partition. And the underlying storage, let's say Kafka or Pulsar, they will be balancing, they will be grouping your services by provided ID. So here I'll be just using, Sergei watching. And same thing as in Kafka. We want to read from the very beginning of every partition. So I pass the subscribe action. I already have this send an event every second, so I'll just drop it because we already have some events, and hopefully we'll see more. And actually, let's just write the whole thing from scratch, because it should be easy, right? Otherwise, I'm just, selling some weird stuff to you, and I'm obviously not selling. So anyways, when I subscribe, here we go with some reactive stuff. And in reactive frameworks, you have a lot of different operators. It takes some time to learn them, but as soon as you learn them, you will be surprised at how it transforms your message processing pipelines or event processing pipelines. But anyways, here we'll be using the famous flat map operator. And what I get here, I get subscribe reply. Quite obvious, but anyways. And if we inspect subscribe reply, we'll see that there is get assignment field. And this assignment thing is of assignment type. What is assignment in terms of Liquidus? Well, you need to describe the process of some consumer being assigned to certain partition. In Kafka, it is hidden behind. Like you just poll, and the assignment happens automatically. And you have assignment listeners. In Liklus, as I said, it is reactive friendly and reactive first. And in reactive programming, it's easier to describe such things in more explicit way. So here we have an assignment.
It's basically like a consumer group.
It's a fact of some instance from this consumer group being assigned to some partitions.
Okay.
Some partition.
Okay.
In fact, if we inspect assignment, we will see get partition, get session ID, and stuff like this. But anyways, I'm not listening to the events yet. So I need to start listening to the actual events. For that, I need to start receiving. And receive request, I can just set assignment. So that now I'm receiving them.
Okay. And where is printout?
So yeah, if I run this code, nothing will happen. We will not be even connecting to Liklus yet. Because in reactive programming, everything is lazy. So I need to somehow trigger the processing. For example, I need to trigger it by calling subscribe, which is the only action in reactive programming that will start everything.
Mm-hmm.
But since I don't want to release this thread and everything is non-blocking in reactive by default, I want to actually block my main thread until I receive the very last item from the queue.
Mm-hmm.
But the queue will be infinite, which means that I'll be listening forever.
Mm-hmm.
And now I only need to add some logging so that we see that we receive more items. So we have subscription. On subscription, we receive. And maybe to just make it a bit more
complex.
Make it nicer or complex. First of all, I want to set format to Liklus event, not just binary, because I want to receive cloud events. And also, I want to extract this event from the receive reply. Get event.
So essentially, in this, it's also some sort of like a wrapper that underlying reactive client will wrap this response, right? So this is why you need to extract the actual payload from it.
As you can see, Liklus supports multiple formats. Previously, it was only supporting binary protocol. Now also cloud events are supported. And otherwise, we'll be just receiving events or payload. But since we want to be more specific and we want to receive structured events, we are saying I want Liklus event and I want to print out only the content of Liklus event record field. Otherwise, we will also see the whole receive reply.
Yeah.
And it contains a bit more fields than we need if we look at it.
Yeah.
So receive replies somewhere here. Yep.
Mm-hmm.
It's one of either record or Liklus event record.
Mm-hmm. Let's run it and see if we can get some something here. And right now it will be running and listening for other events, right? Okay, so let's do it again. If you receive it, okay. So we just got the live coding. Let's see if anyone else sent something to us.
Yay, my full events.
Hey folks, if you are in a chat, if you can try to reproduce the same events, that would be cool to see. But so far, it's nothing special, right? So far is like couple questions here, Sergei, for you. Can you explain why did you change subscribe to block last? Did not it just work with subscribe?
Let's just try. The cool thing about being at an online event, you can just try
answer.
things.
Yes, perfect answer. Just let's see if it works.
What happens when we subscribe? First of all, build successful. What happens? But actually, what really happens is we subscribe and we instantly release. So that we need to do something like thread current thread join. let's say.
And obviously exception handling.
So that we keep the thread running and it keeps the processing running. And we have options. You can either offload it to some background processing, or you can make it, block until you, for example, receive some event.
So, is it like Monad?
Oh.
Not,
Yes.
Just don't worry. I'm just throwing away the stupid things in the.
Okay.
So what
Hopefully
about memory
nobody...
leaks? Yeah. What about memory leaks? Is it caches messages locally? So Alexander, I think it would be great if you can clarify which memory leaks you're talking about. If
I think I can answer this question.
On the server side?
Yeah, on the server side and also on the client side. Let's do, you know what? Let's do this thing, limit request 1. So that we say this thing, request from this thing will be ignored. And this thing will only request one, just one element. And if we run we get one record and that's it. Does it mean that Litlus somewhere in the cloud just loaded thousands of events and waiting to send them to our consumer? And that's the whole point about reactive friendliness. No, it does not. Actually, we just pulled one record from Kafka and we buffered this one item, then we send it to the consumer, and that's it. Not more than one item. And this request, it went through the network and it reached our Kafka consumer somewhere in the cloud. And this Kafka consumer requested just one. If we want 5 items, then we can request 5 items. And we can also limit rate so that we request chunks, let's say 5 by 5 by 5. And here we can see the offset from 0 to 4. So we just requested first 5 items.
So I think this is one of the benefits. We can answer to Alexander, who asks is this the way harder that like old good REST, to call REST proxy? Wonder if what's the benefits? It's one of the benefits here that we can see that it's not just simple request response and it's just like, okay, so let's pull whatever we have. We can actually specify what exactly we hear. It's RPC. It's not request response. So in this case, you can maybe build some of the what is this kind of like a smart pagination type of thing, right? So with this type of approach, and another question that I have, if I may, when you do this stuff like this, when you can subscribe to this one, can you just subscribe like similar way to only to latest and greatest events, or you just need to subscribe always from the very beginning when you join? The same way it's kind of like how Kafka consumer group works.
Let's try.
Perfect.
So we change to latest, and we wait a second, and we don't get anything because nobody is sending us anything, because obviously our idea of interactive stream wasn't that interactive. But anyways, thanks for sending an event, and hey, we have an event here.
Yeah. So so essentially it is like similar semantics. Okay, let's do something else. Okay, so now we are kind of sort of learn how we can do publish, and the next time, I promise, for next week, I will learn how I can write my producer in Java. For now, I think I'm pretty cool with this, just like producing these events in command line. And again, this was totally unscripted, which is like a hack our way through it. So now,
Wait a second.
I'm waiting.
Before we continue.
Yes.
So, okay, receiving something is cool, right? But that's not the point of Kafka, because we were just doing something like similar to, I don't know, RPC, right?
Yes.
So someone is sending, someone is receiving. Not cool. The cool thing about Kafka is that you can read again, and you can store the offset, right? So we can continue reading from the latest scene offset.
Yeah.
Get what I mean?
Yeah.
But we didn't implement it yet, right?
We did not.
Because
Yes, it was just like it's our simple message bus with in-memory persistent that we have right now.
Yep. But if we change it, and let me just beautify this code a little bit. But we can change that, and what we can do, we can start acknowledging records, which is another cool thing. And for that, we need to say, let's say I receive a record, I log it, and then I acknowledge this record up to the offset.
So it's like committing your offset.
Yep, exactly. So in Liklus, it's called acknowledgement and positions, so that now we can, for example, concat map. I'm not using flat map anymore, but concat map, because I want it one by one, not just diamond split and join. Yep. And here I say reply. So that now, since I already processed it in a way, and let's write some processing, do on next, reply, get event. So I got the event, and I'll just system out println event record to string. Okay, let's just make it nicer. So I did some processing here, and now I want to acknowledge it. And for that part, I'll be using another method called ACK, stands for acknowledge. And here I can either set the fields. I don't want to, because I want to save time, so I'll just use the assignment. It is deprecated, but hey.
That's how I run this in the live streams, hashtag live streams.
Yep. Oh, live. Oh, Jesus. Okay, anyways. Now, every time we receive a record, we will read it, we will acknowledge it, and now we switch to earliest. So we switch to earliest. We run. Really?
It's
you see?
It's the the moment where you're putting some of the boundaries and you hit these boundaries yourself. It's actually very good practice if you think about this, guys. The thing that enforces you to do right thing that you put yourself. This is how I program, because I know that I will be doing some stupid stuff, and if I will not put some of the things for my future self, I will definitely fail. So in this case, we're doing this right way.
Okay, some spoiler here. I didn't want to spoiler it, but anyways. And if we look at the protocol, we can check whether we set all the fields required. Acknowledge request, topic, group version, partition. This one is important. Assignment, get partition. Cool. So now if we run it, then Gradle will not be complaining about deprecated stuff. By the way, that's a cool thing. Make sure you enable deprecate, like fail on deprecated, because otherwise you will never fix your deprecated usages.
Yeah.
But if you do, then yeah.
Your code would be better and everything would be better. So, okay, so what's going on here? So now we have all these messages that we acknowledged, right? So, meaning that, like, if we will restart this application, even though we have an error list, we will not be able to see those, right?
Yep, that's how it should work.
Yeah, okay, let's try a restart and just wait. Like, you just kill your application, I will submit new message, and after that you restart and you should be able to see one message, right?
But actually, if I restart, we should see nothing.
Yes.
And then you send, and we should get the latest offset, which is 9, I think, or something.
9. Yeah.
Boom. But there's another thing. We have a gateway, and as soon as we have a gateway, well, we can also
Can you do
some business logic.
rate limiting? Can you say like I can just like hit enter on my side? It's just like continue to do. Can you like limit me with the say like a 20 seconds or like give me some delays?
Actually, I can, and there is a plugin system that we haven't covered in this episode, but we will in the next episode.
Just like as a sneak peek.
Yeah, exactly. But there is something I can show very quickly. Is a group version, and by default it will be 0. But let's say now I want to set group version to 1. So, what is group version? It isn't a thing in Kafka, right? You only have group name. But in Liklus, you can also assign versions to the groups.
Which is essentially like an epoch type of thing, right? So you can have multiple versions of different application.
Yep, exactly. So that now they will participate in the same group in Kafka. And when you deploy, you'll not be deploying a new set of consumers, but Kafka will load balance them and will spread the load. But if we run it again, first of all, we should see, we should get all the events. But what we also get is this fancy field. How cool is that? Liklus just detected that we replayed events because we already seen them in the previous epoch.
If you do, if you change the group version right now, so in this case you will not be able to, you will not see replay, right?
Because I acknowledged, yes. So if I change it to 2, oh, wait a second. This version have never seen this this event, but the previous one did. But to test it, you can send another event. So just boom, and there is no replay because that's a new event. Our system have never seen this event before. And let's say we send push notifications. We don't want to send push notification when we already processed this event.
Yep.
So you may implement some gate that will do a check whether we already processed this offset or not. But with Liklus, you get it out of the box. And the groups also are visible. Yeah, you have a question?
Yes, but like, I will let you finish, and after that I will ask this one. Yeah. Nice. So it's also exposed as a endpoint where we can put some dashboard and we can monitor what the groups are.
You can definitely read it from primitives and then render. You can also render how to say, you can also render the lag. For example, here is the latest offset. And if you know that the latest offset published was 30, let's say, then the lag is 4.
That's nice. So question from the chat, like how does Liklus will help with the error handling and this kind of stuff? So the question specifically, what happened if inside a flat map you're trying to do integer parse of message value, and how this will work here? Which part is this? Is it part of the Reactor, the framework that handles this? It's part of gRPC, part of Liklus. Like, who is responsible for handling this type of errors?
It is part of the data, part of the consumer. Sorry, I was thinking about data. But let's say we do something fancy here. Okay, what's the easiest way? So if we have an error in our pipeline, then since we have the acknowledgement part, we will be able to, so we start and we should not be getting the events because we always, Yeah, we also fail. Actually, it will fail instantly. But the acknowledgement part will allow you to deploy a new version, fix the problem, and then, just continue. You can also offload events into some dead letter queue, but this part is application specific and Liklus at the moment, it does not provide any abstraction for the dead letter queuing, but you can have a second topic, for example, and you can publish to the second topic on error.
Why it doesn't fail?
Because we acknowledge it and nobody is sending events.
I'm sending. I just
Do you?
sent yes.
Okay, yeah, because we are not using block last. Okay.
Okay.
And the error is silently ignored.
Okay.
Okay, yeah, now it's failing. So we failed to process something, but we fix it and we'll continue the processing. So it's really part of the application, and just reactive frameworks help here. As I said, you don't need to. So yeah, we just received four more events.
4 more events that I sent before this. Okay.
But I feel uneasy about participating in the stream and not talking about Kafka actually.
Yeah.
So
I think we have 20 more minutes, I think, at least.
More than enough.
Let's do some Kafka. There's some question from Masood about the rate limiting, but we will talk about plugins on the next episodes. We will break this down in detail. So what we're going to be doing right now is we're bringing Kafka into the mix. So in this case, we will bring some of the in-memory stuff out. So when we redeploy this, first of all my fancy messages will be lost. Now, when we will fix this, we will bring some of the Kafka.
So first of all, we need Kafka, right?
Yeah.
And I'll be using Confluent Cloud as the easiest option for me to get some Kafka.
Or like for anyone, easiest option to have Kafka.
Yeah, probably. And we need to have a topic. So I'll just create a topic like events. Just code like this, 32 partitions.
And my dear friends, as you can see here, the Sergei, being as the good engineer, he knows specification for his topic. He creating topic himself. He's not relying on auto topic creation on some defaults. He creating this stuff for himself. He can do this like in the console. He can use this like UI, but like for now we're just using UI. And Alexander, I see your question, but I will bring your question in after we deploy with Kafka, and we will talk about this. Stay tuned.
And I wanted to talk about this thing. It's not related to Liklus, but it's something I want to focus on. Usually I over-provision my Kafka topics so that I can scale them to more consumers. And Liklus supports scaling to consumers and this assignment rebalancing. And if you have just one partition, then it's easier to work with, but you will only be able to have one consumer per group. While with 32 partitions, you can deploy two services, two instances of the same service, and each will be consuming 16 partitions. But then when you get lucky and your product becomes super popular and you start getting like millions of users, you need to scale out. And if you thought about it in advance, then you can just scale the number of servers instances to something like 4, 8, 10, whatever the number is, up to 32. And they will be consuming the events each individually from individual partition. So it's just for performance.
And can you go back to this a little quick to this topic and the configuration of this topic?
Of course. This one?
Retention in bytes.
Okay.
So essentially, it's an infinite retention, and infinite for our events backbone. This is what we want, right? So finally, your your dream, kind of sort of coming into life.
Yes.
All right. So we have a topic next. How we can configure this the Liklus fella?
So with YAML, of course. So first of all, we changed the storage type to Kafka. But now, how should we configure it? I mean, I could of course use environment variables, but then I would expose the credentials from this Kafka cluster.
Yeah.
And yeah, next episode we'll see like a lot of production data in this Kafka cluster from some fancy startups that decided to reuse it.
That's okay. We can you can just do this right now. We can remove the keys after the fact, but like let's make it like a raw and as how you would do this in live hacking session.
Okay, so actually
Don't worry about this.
I already have the credentials, to be honest, as a secret. So I would just apply them as a secret.
And many of you folks, you've seen how you can extract the how to connect Confluent Cloud in my live streams. I did this like yesterday. I showed you like in details how you can pass it in Spring. But essentially, if you let me actually quickly show you. For those of you who just join us for the first time.
Yeah, and I'll write some YAML meanwhile.
Yeah, I will just like quickly show where we are. So we're doing DevX and friends. We're doing login. And in our cluster, if I go to this live streams cluster, there is a API access for tools and clients, and there is a like clients that we can use. Here, most likely Sergei will be using a like Spring Boot version. This is the properties that he needs to connect, and essentially it's just only the just like a URL to Kafka, login and password, and that's it. So now we're looking into storage story. So while the Sergei is typing, I will be explaining what he's doing. Essentially, like we will bring this secret already into our Kubernetes cluster. Now we need to bring this into the same pod that will be running leakless. So the leakless will be able to read the property file from this secret. And essentially, this is just another YAML / Kubernetes magic to bring this into the story. And okay, I also noticed that using Jib because I guess it's a part of Spring Boot that comes with linkless, because this is where configuration usually goes from the Jib convention app/config.
Oh, really? I didn't know.
Yeah.
No, I just know that Spring supports config folder.
Yeah.
So I just dropped it into the config folder. It's a hack, actually. There's a better way of doing it, but I'm obviously not a Spring expert. I'm just a user. So my previous pitch about Spring was, I'm using Spring, but I have no idea how it works. Anyways.
No, I mean it's a valid point. So essentially, the couple things that you can do as a user. You can inject the secrets as environment variables. Spring also supports that, but just like again, bear with us for we're doing like whatever easier to demonstrate.
Mm-hmm. So I just dropped some more YAML, and here I place it records type to Kafka. I added a volume from Kafka secret, the one we created, and as you can see, it's here. And I mounted under app config as read-only secret. So I'm just configuring my Spring application, and that's another thing about leakless. It's a standard Spring application, and similar concepts for configuring Spring, such as environment variables, properties, arguments, and file mounts will also work, and you can actually use YAML for configuring Spring, right?
Yeah.
So for those who love YAML, everything can be in YAML. Can't wait to program in YAML. But anyways,
we have Kotlin for that.
Yep, exactly. I just changed a bit of thing, and now if I deploy it again, so basically once again what I changed: records type storage to Kafka, and required Kafka properties just so that I can connect to super secure Kafka instance somewhere in the cloud.
Yeah.
We deployed it. If we go to Octant once again and open the logs, successfully logged in. So now we are connected to Kafka, and everything we'll be doing now will be doing things with Kafka
And
not,
as you can, I'm switching to quickly to Kafka side of things. I'm showing that there's a consumer that connected to this topic. So where's the consumers? And Sergei is watching. This is one of the consumers that we have here. It's on the Confluent Cloud UI. Now let's try to produce some messages, right? So if I will do the publish, I will do publish. Still have it here. Still have it here. Let's see if we can see it in on the consumer side. Sergei is watching. 0 messages behind. Number of consumers. Why? It's maybe it's my UI doesn't show correct thing, but it should be there. And
it takes some time to render it. I know it's
on
but
the UI, yeah.
At least in the topics section, we can see that. Can you produce some?
Yeah. So if I will just like write a new message into topic.
Boom. It's here.
Just give me a second. I'll showing this on my UI as well. Messages. Come on. Yes. Okay. So, and as you can see here inside this, we can see there's some header stuff and value. But why I don't see value? Why we don't see value here?
Because you didn't set any. You only set headers.
Okay. So when this part is that we're sending is actually a header, right? Information about this part.
But if I do set some value to, let's say, an empty object, like why not?
Yeah.
Oh, okay. Then I messed up the data. I need to encode it as space 64. Pardon? But it's all live.
Okay, and now if I switch to here, I should be able to see the value is an empty object, which is pretty cool. I think it's pretty nice. Now what do we have here? I want to bring the question from Alexander again. Alexander is asking, why would my Kafka producer and consumer work faster when than the Kafka producer and consumer? I think Alexander is trying to ask if I will using Kafka as my backend for Likless, and I will be using this to produce those messages. Will it be faster? You know, I can make an assumption that Alexander is from Russian-speaking country, that the people care about the performance so much. So that's why the questions about the about performance and how the things are faster. So you want to take this one?
Yeah, sure. So first of all, you should keep in mind that under the hood, internally, Likless will be using the same Kafka client, and it is an abstraction on top of it. So you will never get better performance than the Kafka client gives to you, but it's only true when you use the consumer correctly. When you properly configure it, when you consume, good amount of records and not like thousands of them at once. And since Likless also encourages you to migrate to the reactive style, it means that after the migration, you may get better performance of your system because you migrated to this reactive approach. So you're not getting better performance because Likless is better at performance, but you get better performance because the style you're using is better. And speaking of performance, Likless was created, and probably I should have mentioned that I created Likless at my previous job, and it was in production for more than 2 years. It was a big startup in Germany in health tech, and we were processing quite good amount of events, not just bytes, but we were measuring events. And I can say that the performance of the system was very good. And very good is, of course, very, something you cannot measure. But I can say that the way Liklus helped us definitely outperformed anything related to what would be if we would be writing consumers ourselves. And in fact, one of the reasons why we created Liklus and not just a shared library is because we wanted to abstract away all the details of using Kafka client, because it may not be easy. And when you use Kafka client directly, you also go to Kafka directly. While with Liklus, you get an abstraction. And abstractions always cost some of the performance, but you can also run the benchmarks, by the way. There is a branch with benchmarks in Liklus. I'll update it to the latest state and probably will merge soon. But from the benchmarks, we have also seen good numbers.
So one of the questions that we have from Masoud is why not to use Reactor Kafka then?
Maybe as a current maintainer of Reactor Kafka, I can answer because I work on both projects, Liklus and Reactor Kafka. First of all, Reactor Kafka is also a wrapper around Kafka client. In fact, Liklus attempted at using Reactor Kafka internally, but then migrated to the direct usage to improve the performance. And also there were some major bugs in Reactor Kafka that I now fixed, but it's to be released. Please watch the releases of Reactor Kafka. And that's a good question, by the way, because as current developer of Reactor Kafka, I encourage you to try the new version. But also, as a current developer of Reactor Kafka, I can say that if your goal is to consume events from some event system, I would recommend going with Liklus because it gives you an abstraction and a gateway that you can extend later. And please do join next streams because we will be doing some crazy stuff with Liklus that would not be possible with just Kafka or some other system.
This is something that I always wanted to point out for people. So maybe right now, usually I'm answering this code from the Back to the Future. You folks might not be, understand this right now, but your kids gonna love it. Essentially, we will touch base on some of the things along the way, but right now we're just trying to break down some of the mechanics, what we're doing here. Because if we would do this otherwise, if we would start with some like weird, obscure use case first, in this case, it will not make any sense at all. So right now, you understand how we build up this. Think about this as just right now the service on top of Kafka and what kind of benefits it will gives you, or maybe not on top of Kafka, or maybe we even can find the different ways how we can integrate. So yeah, in this particular case, so what did you learn today? Okay, I think we will start wrapping up. You can still throwing some questions at us, but I think we will be wrapping up a little bit. So what did you learn today? What did you learn today? So first of all, you learn about simplest possible way. Let's talk about this as a kind of like a gRPC proxy maybe for Kafka. And you learn a little bit about Liklus and some of the internal bytes. And now we know how we can persist those events into Kafka topic. We see those events in the Kafka topic, and the standard tool is able to read those events, which opens up some of the interesting possibilities for us, right? In future. So Sergei, what's your let's make a sneak peek for our listeners, and we will be wrapping up some of the things.
Sneak peeks. So we just deployed the gateway, but we haven't played with the gateway functionality. We just discovered how we can abstract away our event storage, but we haven't got much out of it. So next episodes we will be talking about what event gateways essentially unblock, what they help you doing, how they help, and why you should use event gateways instead of going directly to Kafka. And such examples could be JSON schema at publishing. An example could be event upcasting, where you change old events to the new structure without changing all your consumers, all 50 or 100 or how many consumers you have. You don't have to change your current code if you want to change the structure of your events, for example. All of that is possible as soon as you have a centralized access to the storage, and as soon as you have a simple protocol that helps you changing things and not proxying, but gatewaying things. And please, excuse me for going back to the questions, but I see that we missed one question about the storage position and the role it's playing here.
Yeah, go ahead.
I will go back to the code and I'll show it in the code. So we acknowledge records and we say, okay, I just processed the record up to this offset, but we need to store this information somewhere. We need to store the fact that consumer with this group, with this version, have processed partition number X up to offset number Y. And in Kafka systems, usually people commit to the same Kafka instance. That when you acknowledge, it goes to Kafka. Kafka uses an internal topic to store the acknowledgements. It is an option, but what we discovered in my company is that when you migrate from one Kafka cluster to another, you may have issues replicating this information, or you may want to make sense out of this information, like this isReplay flag. For that, you need some sort of key value storage that you can read and write to, and position storage is exactly that. And as everything in Liklus, position storage is pluggable. And as you can see, we can update positions, we can find them, or we can actually stream positions from the storage, and we can also run some subqueries on them. There are some built-in implementations, like for DynamoDB, for Redis, but you can also write your own for Cassandra, for like the in-memory one is the simplest. Although it gives a lot of inspiration how to write such position storages.
We can try Hazelcast as like old good old days. They should have a
certainly can.
They should have a cluster like the cloud version, so we can try it out.
Mm-hmm. Yep. And when we read, for example, when we query Prometheus, then Prometheus will be reading from the position storage. So it will not be going to Kafka or any other record storage, but it will go to this fast key value storage so that we separate positions or offsets from the record storage.
I think one of the interesting exercises would be in future is to run some sort of like a disaster recovery use case. We kind of like we'll be switching this application from multiple different data centers and see how the application would be deployed in another data center will be resume from the point where application in another data center stopped. So
I'm pretty sure one day I'll accidentally drop some of our resources. So maybe this disaster recovery will be an unexpected episode of our series.
Yeah. So I think it's going to be. We do have the few interesting topics that we want to talk about this, and specifically the topic about like application evolution and schema evolution. We also want to make it interactive, but like without like going into much of the details, without going into this super deep sneak peek. Stay tuned for new episodes. So for that. Right now, I'm pointing to the Sergei's Twitter. Just point the follow Twitter, Sergei. Point to my Twitter. It's somewhere here. It's just weird. I'm just like it's my.
Oh, we can do bombs. Like
we can.
Where is it?
The different.
Is it really? I think.
Yay! It's close.
We did it.
We did it. So
Good enough.
follow us here. Stay tuned. Subscribe to this channel. We will be going live in this channel. Also, comment if you're watching this as a recording. Let us know what you think about this. What kind of topics we might didn't cover. And as always, I want to say huge thanks to my friend Sergei that agreed for this experiment. I hope the first episode was not how is saying this? It's not failed. Yeah, there's no. It's not a bad bad crepe. How we can say it? How we say it in Russian. So stay tuned for new stuff. And as always, have a nice day.
Thanks for having me.
And thank you for agreeing to do this. Thank you, Alexander. Alexander saying the best of luck for us, and bye.